Hi, this is Mr. Royks. I'm going to take you through a couple of practice problems dealing with multiplication and division and dealing with significant figures. So if we look at the practice problem, we're going to start with multiplication. Reminder that the rule on dealing with significant figures in multiplication or division is that our answer cannot have more significant figures than the number with the least number of significant figures in the operation. So if we look at the first one, 33.42 times 2.35, if we put that into your calculator, you should get an answer of 78.537. So now when we go to write that answer, if we look, the 2.35 has three significant figures. The 33.42 has four significant figures. So when we write our answer can have no more than three significant figures. So we need to round our answer to the appropriate number. So the answer is going to be 78.5, right? And the 37 get dropped. Alright, so let's look at the next one. We have 0.0043 times 0.3256. So when we do that mathematical operation in the calculator, we are going to get an answer of 0.00140008. So now how many figures should we have? Well, if we look, again, this has four significant figures. This has two significant figures. So our answer should only have two significant figures, which would be the least amount. So we get an answer of 0.0014. Okay? Or if we wanted to write that in scientific notation, we could write that as 1.4 e to the negative third. Okay, that would be the scientific. So if we look at the last one, we have 88.1 times 14.651. We get an answer of 1,290.7531. So now if we look at number of significant figures, 88.1 has three significant figures, and 14.651 has five significant figures. That means we can only have three significant figures. Now this becomes a little difficult because if you look, we only have three significant figures, the 1, the 2, and the 9 would be significant, and everything following that would be insignificant. Easiest way to deal with this is to right away put your answer in scientific notation. And if we say this is 1.29 e to the third, now we've taken care of the fact that we've followed the correct number of significant figures, but we don't necessarily have to worry about this 0. We could write the 0, if we wrote it in regular standard format, we just write this as 129 0 with no decimal point. And that would get us to follow the rules for significant figures as well. So now if we look at some division, if we do say a number like 56.2 divided by 1.094, and we do that problem out, what we get for an answer is 51.3711 and all those other digits, but really what we need to know is how many significant figures. So 56.2 has three significant figures, 1.094 has four, so that means we should have an answer rounded to only three significant figures, and that would give us an answer of 51.4 because we'd round from the 7 up to a 4 there. Okay, so that would be the answer there. If we look at another problem, we have 360.50 divided by 43.1. So we enter that into the calculator. We get an answer of 8.3642 and on. In this case, we look at significant figures. This one would be considered to have 5 significant figures because this trailing 0 is significant. This one here has 3 significant figures, so that means our answer needs to be 3 significant figures. So we get an answer, of 8.36, and that's a rounded answer. All right, and if we do another one here, we have 0.25 divided by 1,280.6. Okay, and right away it gives our answer in scientific notation. Okay, and so again, significant figures: 0.25, 2 significant figures; 1,280.6, 5 significant figures. So the lesser number is going to be the 2, and so our answer would be 1. I caught myself there. Not 1.9 because we have to round up, so it would actually be 2.0. Okay, this 0 is significant because it trails that, and then it would be e to the negative 4th. Okay, so that would be the correct number of significant figures for that problem. I will post a second video with some practice problems, but hopefully this gets you started in on this.